So, how do we simplify radicals that are not perfect? There are a couple of methods here. We can pull apart a number like 20, which is not a perfect square. These are our first few perfect squares. We can pull apart 20 into a product of its factors. So we can do the square root of 4 times the square root of 5. I can also do that under one radical. But the point is that it's not just any two factors of 20. We could not do the square root of 10 times the square root of 2. That would not help us. We only use perfect square factors. So the square root of 4 is 2, and root 5 does not simplify, so that stays under the radical. The problem that we run into is, what if a number has more than one perfect square factor? And there you might want to use the factor tree method. So for number 2 here, we know that we cannot take the square root of a negative, so we're going to pull that out as I. I'll put it right there for now. And then we need to factor 72. Well, 72 is even, so I know that I can divide by 2 and get 36. Anytime I factor a number, I cross it out. There are a few factors of 36. There's 6 times 6. And we are prime factoring. So I'm breaking this down into its prime factors. Here we have 2 times 3 and another 2 times 3. So since we are looking for a square root, I look for pairs. I have a pair of 2's that I can pull out, and I have a pair of 3's. So we broke down the 6's here. So a square root, we look for pairs and pull them out once. So we have our 2 that we pulled out once, our 3 that we pull out once. Left under the radical is this lone 2. The 2 that did not have a pair. So the pieces that we pull out, if you have multiple pieces on the outside of the radical, or multiple non-paired up numbers under the radical, you multiply what's there. So we have a 2 and a 3 on the outside, multiply that to get 6. And the 2 stays under the radical. And the other way this would have worked out is to take, oh, I forgot my I. Don't forget your I. I would write it as 6i root 2. You can put the I on the outside, but you are likely to put it under the radical accidentally. So this would have worked out as 36 times 2. 36 being the biggest perfect square that goes into 72. The square root of 36 is 6, so that would reduce to 6i root 2 either way. We can look at one more. No negative here. So what makes 96? Again, it's even. So we can do 48 times 2. 48 is even. We can divide that by 2 to get 24. And again, we can break this up however we want to speed things along. I'll break up 24 into 8 times 3. And then we cannot break down 8. Sorry, we cannot break down 3, but 8 is 4 times 2. And then 2 times 2. So let's look at our pairs. There's a pair of 2's. Here's another pair of 2's. And then it looks like a lonely 3 and a lonely 2. So we have a pair of 2's, pull out one of them. put it on the outside of the radical. Here's another pair of 2s. Pull out one of those, put it on the outside. What was left on the inside, the pieces that did not have a pair, and again, here we go. And again, if we pull out multiple pieces on the outside, and if multiple pieces remain on the inside, we multiply what's there. So 4 root 6 is our answer, which means the other way we could have gone is the square root of 96. The biggest perfect square that goes into that is 16. And the square root of 16 is 4. So I hope that helps. Let me know if you have any questions.